us, though, should be listening to me, with the exception of like 2 people that already checked their study guide yesterday. Just, you know, quietly keep working. But this should be fairly quick, you guys. So problem number 1. So level number 1 on your test. Now, somebody asked a wonderful question in the last class. Level number 1 is literally going to be exactly like this. You'll be asked whether it's a dilation or not. Now, you're going to need to do a little bit of math to prove whether it's a dilation or not, right? So let me show you what I personally did. So so remember, for it to be a scale drawing, which is what you do when you create a dilation, you need to have the same scale factor for every corresponding side. So what I did is I took each corresponding side, so 9 and 6, for example, and I divided 9 by 6. Now, I'm kind of emotionally scarred from when I taught 7th grade, well, not when I taught 7th grade math, when I took 7th grade math. Fractions and decimals, not exactly my cup of tea. I know math teachers aren't supposed to say that, but that's why I really didn't enjoy teaching 7th grade all that much, and why I definitely moved up to 8th. However, fractions can be very helpful when you are doing scale factor, because you don't have to divide it and get a decimal or anything like that, because we know that a fraction is really just a division problem in disguise, right? So I can do 9 divided by 6, and instead of dividing, I can just simplify that fraction. So what's a common factor for 9 and 6? 3, exactly. So I can divide them both by 3, and that gets me 3 over 2. So if I am able to take my other sets, my other corresponding sides, and divide them out and get 3 over 2, more than likely, it's probably a scaled copy, which means that, yes, it would be a dilation. So I'm going to do 6 divided by 4. Common factor there is 2. Does that simplify to 3 over 2? It sure does. So chances are it's probably a yes, but I'm going to do the third side anyway to make sure. And I purposely avoided this one because, you know, that decimal right there. So what we're shooting for is trying to see, does this simplify to something that will have a 2 in the denominator? What's 5 divided by 2? 2.5, right? And then 2.5 plus 2.5 is 5, plus another 2.5 does give you 7.5. So I would do the easier ones first, which in my opinion, the whole number ones are easier, and then just use them to verify if you do have a decimal like that. So yes, because every one of them does have that same scale factor from their corresponding sides, it will be a yes. Now, somebody asked a great question in my last class, and they said, do we have to show our work for a level 1 question, or is it fine if we just do yes or no? So technically, you're fine with just doing a yes or no. However, what if you make like a small mistake when you're doing the division that makes you say this wasn't a scale copy? So what I would do if I were grading that test and I saw, shoot, I know this kid knows what a scale copy is because they told me no, because they divided and got 2 different numbers. They just divided wrong. More than likely, I would give you the credit for that question because you know what a dilation is. You know that a dilation requires you to know what, that a dilation requires having the same scale factor. So if you said no because you divided wrong and you got different scale factors, but I could see on your work that that's what you did, I would probably give you credit for that question. So think about that throughout, because the standard is, can you identify a dilation? Not, can you divide? So keep that in mind, that would you technically get this question right if you just wrote yes? If you wrote no, but it was because of a small error, that might cost you credit for that question, when if you'd shown me some work, I could give you a little grace. Does that make sense? So technically, you only have to say yes or no on Friday, but you probably want to say a little bit more than that. Yes, ma'am. All right, let me answer this question. Okay, so those are all the possible combinations of things you might see for a level 1 question. There will be 1 on the test on Friday. That's it. Questions about level 1? Okie dokie. Okay, level 2. What does that mean if I write it in red? It's wrong. Okay, lots of people do this on the test. It's literally the same mistake every darn year. Okay, so they do notice, hey, these are corresponding. Okay, so we do notice that. And so we should use those to find the scale factor. So what a lot of people will do is say 30 divided by 24, which makes sense to use division to figure out what that missing scale factor is. And then because it's a fraction, fractions do work to our advantage here. So 30 and 24 both have a common factor of 6. And they say the scale factor is 5 over 4. Here's my question. Is 5 over 4 a number larger than 1 or smaller than 1? Larger than 1. What did this image do based on the pre-image? It got smaller. It did not get bigger. So what you've done is you've gotten the right digits. You just have them in the wrong order. So it's not 5 over 4. It should be 4 over 5. So the strategy of using division and keeping that scale factor as a fraction is a good one, but make sure that if it's clearly going smaller, if it's being shrunk, your smaller number needs to be on the top. So 24 divided by 30, not the other way around. So in this case, our scale factor would be 5. Okay, questions about number 7? Okay, number 8 is basically the same question. It's just going in a different direction. This time, the pre-image versus the image, is it an enlargement or is it another shrinkage? It's enlargement this time, right? So you are going to put the larger number. I'm just going to use those two, but you could have used 21 and 14. Put the larger number on the top. Put the smaller number on the bottom because we're looking for a scale factor that's larger than 1. So a common factor for those would be 4. So your scale factor would be 3 over 2. Questions about number 8? All right, so there will be one scale factor question, exactly like number 7 or 8. There will be one center question, just like 9 and 10, okay, to get to level 3. And so let me start with number 9. So I think it's helpful to find the scale factor first in order to figure out where the center must be. And since these are diagonal lines and so it makes it a little hard to count, here's what I would do if I were you guys. I would measure the horizontal and the vertical distance of one of the slanted sides. So see how this one is 6 and my horizontal distance is 2. Here, my horizontal distance, my vertical distance is 3. My horizontal distance is 1. So what happened? Oh, and let's pay attention to this part here because a lot of people might say, actually, I'm going to go ahead and tell you, a lot of people might say the scale factor was 1/2 because it got smaller by 1/2. But what would be wrong with that? Doesn't follow that prime notation, exactly. Prime notation shows it got bigger. So the scale factor is not going to be 1 over 2. The scale factor is going to be 2 because it got twice as big. So now we need to figure out still what the center is. And here's what I would do if I were you. First of all, besides the fact that the scale factor made the image larger, it should have also pushed M farther away from the center. C and D, it didn't really, they're still like, both of them are still like the same distance away from C and D. So C and D are automatically going to be out of the running because if C or D were the center and you did a dilation that pushed the image farther away, it would be like down here somewhere because it would be farther away from the center. I drew that terribly, but hopefully you get the idea. So we know that C or D are not going to be my two options for a center point. So instead, I'm going to focus on A and B. And you are going to have straight edges, so this would totally work. I would just draw straight lines from what I'm testing as the center point, so B, and I drew a straight line to the two corresponding parts right here. So you can see pretty well that that whole distance is now twice as large, right? Originally, this little point on the right just went here, but now it's double the length away. So that's how you know that the center point is B. If you even just try to draw a line from A, you can't even draw a line from A to the corresponding sides on the other two triangles. So that's another reason that you know it's not going to be A, it's going to be B. You need to be able to draw a line to show that difference. Okay, so questions about number 9? Alrighty, number 10. So first of all, let me figure out the scale factor. I would do that same thing where I just look at my distance. So that's 3 and 2 of that slanted line. And then on the corresponding side of the other one, 1, 2, 3, what is it, 6 and 4. But this time it's this time it is getting smaller because my image is smaller. So instead of 2, my scale factor this time is 1/2. So then these are actually a little easier to figure out because they're nice and lined up for you. If I draw a line, I think A is probably going to be the center, but let me prove it to you. If I draw a line from A, see how it lines up nice and neatly right there? My pre-image was all the way over here at the end of the line. My image is now halfway closer. So it's right in the midpoint. So that's how you know that A is the center of that dilation. If you need extra practice problems to practice the center, I would say that's probably the one that people have the most trouble with the most. You guys had on your test for levels 1, 2, and 3 will be just like the ones for levels 1, 2, and 3. Level 4 is where there's a little variety because obviously I can't come up with every possible example of a level 4 you might have. But so starting off, first of all, this isn't asking you about coordinates. It's not asking you about anything. It's just asking you about length. So if AB is 3 and you dilate it with a scale factor of 5, how would you figure out the length of your image? You would just do 3 times 5. Now, this is a level 4 question. I gave you centimeters as a unit. Do you think I'm going to give you 100 if you leave off the centimeters? No. Okay? If units are provided for you, especially on a level 4, if you're trying to shoot for 100, make sure that you include units. So not just 15. I don't know why my M is turning out so crappy on there, guys. There we go. Okay, if you do 3.7 times 3, if you did that correctly, you should have gotten, if my calculations are correct, it should have been 11.1, right? And 11.1 centimeters. Now, to multiply by 1/5, I personally would just do 3 times 1/5, which means you have 3/5. But I saw some of you guys changed them into decimals, which is fine. I wouldn't do it that way because it requires an extra step, but doesn't matter to me. Sorry, this thing is doing that stupid thing it does again. At least we're almost at the end. I got to figure out what the heck is going on with that. Okay, so 3/5. Don't forget about your centimeters. There we go. And then last, I did just growl. I was like, okay. I turn into a really big baby when my technology doesn't work. Okay, and then last but not least, if you don't know what the scale factor is, and we're going to use the letter S, you're still going to multiply it by the original distance, right? So you're still going to do 3 times that. We're just going to represent it algebraically as 3S. And I realized, I think I told you guys before that I would never use S as a variable, and I realized that just made me a liar. Because my 5s do look like S's. So make sure you're clear on your notes that this is an S, but the rest of it is 5s. Okay, any questions about number 10? But you won't find out about it until you get to high school geometry. Yes, dear?
Where it's like, since you have the 12 centimeter and 15 centimeter, you could tell you figure out the scale factor and then you could apply it to the 8 centimeters.
Oh, are you saying because you like doubled, since you doubled the 4 to get 8, you would double the 5 to get 10, kind of?
Sorta. It was just since the scale factor was 1 1/4, I think, and then it was just 1 1/4.
Oh, 8 plus 2. Oh, yeah, that's smart too. Yeah, good job. So remember, if you're not given one of those corresponding sides, at least here in 8th grade / algebra, we don't know how to do that yet. So all you could find was that one side. Okay, that's a good strategy too, ma'am. Yes. At least number 12. All right, so it says this one is not, so here's what you should not do. You should not say, oh, well, that is 2, 5, and the scale factor is 3, so my new A prime is going to be 6, 15. First of all, there's not enough room on the grid for you to do that. But when does the little trick where you multiply the coordinates by the scale factor work? What has to be the center? Yes, Dia? The origin has to be the center. In this case, the center is not the origin. The center is C. So I'm going to look from here. So in my original, in my pre-image, B is 2 units away. So if it's a scale factor of 3, B prime needs to be 6 units away. So B prime would be right there. Then my A prime, because in my pre-image it was 3 units away, 3 times 3 is 9, so it's going to be here. Oh, wait. No, it's not. It's going to be right here. So my coordinates for A prime will be 2, 11. My coordinates for B prime will be 8, 2. And then whenever you dilate a shape, does the actual shape change besides the size? No. So what happens to the angles? They stay the same. You can see that my C was a 90-degree angle. It's still a 90-degree angle. So as long as you say something along the lines, you could say this a couple different ways. You could say angle A is congruent to angle A prime. And then angle B is congruent to angle B prime. That would work. Or you could say they're all congruent because they're the same. Something along those lines, because you just need to know that a dilation changes the size, but it does not change the angles because that's how it gets the shape in the first place.